Okay, let's have a quick look at this indices questions. Now, before we start, let's just quickly have a look at this. It says x to the power 4 add 7x cubed multiplied by x over 9. Okay, so using BIDMAS or BODMAS, let's deal with the multiplication first. I'm going to do this in red. Okay, so that will be 7 times 1/9 is going to be 7 over 9. Okay, write that clearly. And then x cubed times x is going to be x to the power 4. That's going to be added to this x to the power 4, which is whole. And then that's going to be to the minus a half. Now it's added. Now, since they are both x to the, quartic powers here, x to the power 4, okay, we can then add these together. Now, remember, this is one whole, okay, and with the whole, if I times top and bottom by 9, make it into it, because a whole is 1 over 1, which is the same as 9 over 9, okay. The reason why I've done that is now I've got denominators are the same. And if the denominators are the same, I can then add the numerators. So the next line here would be 9x to the power 4 add 7x to the power 4 all divided by the 9. And that is to the minus 1 over 2. Now, what I'm going to do is, if I add those together, I'm going to get 9 plus 7 is 16. I'm going to 16 to the power x to the 4 over 9. And that is all to the power of minus half. Now, here is something that we could do important here, because this is a minus, okay, which means a reciprocal really. So all this is 1 over. Okay, so if we want to get rid of this negative, we can just turn this fraction upside down. Okay, because it's a reciprocal. So that will become 9 over 16 x to the power 4. And that will be all to the power of a half. Now, before I write, I'll write it here. Now, that power to the half, you should know, means square root. So it's square root all of this inside 16x to the power 4. Okay. Now what we can do with square root here, we can just take them and square root each one. So I could get 9. I could square root that. I could get 16. Square root that. I could get x to the power 4 and square root that. So that's possible. You can do that. You can square root each one. If it's a product, then square rooting each one is the same. Okay. Trying to think. It's like saying this. If I had 100 over 4, okay, which I know is 25. 100 divided by 4 is 25, and if I square root 25, I'm going to get 5. Well, another way I could do this is by doing 100, square root that, 4, square root that, square root of 100 is 10, and square root of 4 is 2, and 10 divided by 2 is also going to give me 5. I'm just going to put that there just as a thinking bubble, so you understand that when you're square rooting a product or a quotient, you can separate the square roots and it will still give you the same answer. Okay, you can do that, prove that algebraically too if you want. Okay, so by using that rule, we can square root of 9 is 3, square root of 16 is 4, and the square root, when you square root something with a power, you just half the power. This is half in it, so half that will be x squared, and that is it. I would probably leave it like that. If you want to write it as 3 over 4 and bring the power up, you can write it like this, but I would probably leave it. Depends, if you're differentiating, then you might want to learn how to write it like that, because then you can take the power down. And if you want to just substitute, I would leave it like that. Okay, substitute a value of x in. Okay.